Welcome to CS 1401 Video 13.1. In the last set of videos, I covered software testing. So now I turn to what to do when the testing, or just plain trying to run a program, reveals a problem. Rare, really rare, is the program that, when first written, has no mistakes. Problems in a program, a misspelled or uninitialized variable, an incorrect logic test, a missing argument, the wrong loop boundary. These problems are called bugs. The story has it that legendary computer pioneer Grace Hopper was having problems with a mainframe computer. When she looked inside the computer, she found a moth that had caused the problems. She pulled out the moth, made sure that the computer was now running correctly, and declared the computer debugged. For our purposes, debugging is the process of finding the cause of a problem with our program and then revising the code to resolve the problem. Integrated development environments usually provide a suite of debugging tools that help programmers find and fix problems. Here, though, we'll start with the basics of debugging on our own. When our program encounters a problem, usually revealed by testing, there are 6 phases of debugging that we can apply. First is issue recognition. This involves identifying exactly what it is about the program's behavior that seems incorrect. Maybe the program is producing the wrong result in a test case. Or maybe when we run the program, the runtime environment reports a problem, such as an array index out of bounds. The important thing here is to recognize the nature of the problem we have to solve. Second is intelligence gathering. This involves examining the program to understand the way that it works and the way that the error is being produced. Is a loop terminating too early? Or maybe the loop never executes at all. The third phase is diagnosis. This involves identifying the specific cause of the symptom, the bug itself. The fourth phase is prescription. This is planning how to fix the bug. 5, the phase is response. This involves following the plan to fix the bug. And phase 6 is verification. This involves checking that the bug is now fixed and that our fix has not created other bugs. In many cases, I don't follow all of these steps. A brief version of this process would involve recognizing the issue, diagnosing and fixing the problem, and checking to make sure that the fix worked. Sometimes it's pretty clear what caused the problem. Other times it's much harder to figure out what went wrong. In these harder cases, one way to gather intelligence about the problem is to insert, for purposes of debugging, statements in the code that print out values of the variables at the point in the program's execution. Remember when we traced pseudocode programs by writing out for each statement the value of the program's variables for that state of the program? Well, inserting debugging print statements is effectively doing the same thing, outputting the values of the variables for states of the program that you want to check. You can then compare the values printed by the debugging print statements with the values that the variables were supposed to have. If a variable has a value that you didn't expect, then that provides a major clue for finding the precise problem. In video 12.3, I showed an example of white box testing when I created my test cases for the program month, name, and length. In this video, I'll try debugging a Java program through black box testing. The program calculates grade point average, in this toy example for 2 courses. The program asks the user to enter a grade, expressed as a number between 4 for an A and 0 for an F, and a number of credit hours, between 1 and 4, for each of 2 courses. As a black box approach to testing, let's try it out. I'll have the first course have a grade of A and 3 credits, and the second course have a grade of C and 3 credits. So I expect the program to print out 3 as the resulting GPA. Whoops, that wasn't what I expected. Let's open up the program. It looks right. The first thing I'll do is insert a debugging print statement to make sure that the values are getting into the variables correctly. I'll print out the values of each of the variables in this order: grade 1, credit hours 1, grade 2, and credit hours 2. I'll recompile and try it out with the same values I used before. Okay, the variables have the right values, but I'm still getting the wrong result. So the only other place the program could have a mistake would be in the calculation of GPA. The arithmetic expression looks right. I'm adding the grades times the credit hours and dividing by the total credit hours. Wait, I think I see the problem. The divide operator has higher priority than the addition operator, so my expression is first doing the divide, then doing the adds. That's backwards. Let's see if my diagnosis makes sense. I think the program is calculating 4 times 3 plus 2 times 3 divided by 3 plus 3. Sure enough, that adds up to 17. Yep, that's the problem, all right. I can fix the problem by using parentheses to specify a different order of evaluation. Here's my revised code so that the addition occurs before the division. I'll comment out my debugging print statement, recompile, test with the same values, and sure enough, the program produces the right result this time. Let's also try the program with some other slightly more complicated values just to be sure the program's working correctly. With these values, I'm expecting to get 3.5 as the resulting GPA, and that's indeed what the program produces. Okay, that's an introduction to the process of debugging and one example of debugging a Java program. In video 13.2, I tried to debug 2 more programs. Please join me to see how well I do.